And welcome back. This is Unit 12, Lesson 5. We are factoring polynomials again. This is the second round. So this time your objective is here, and the difference is that our leading coefficient is going to be something different than 1. So instead of x squared, we're going to have like 3x squared or negative 5x squared, whatever it is. Okay? But that doesn't change how we're going to solve this, since I taught you the very first lesson of factoring how to solve this and prepare you for when there's a leading coefficient other than 1. Okay, so we're going to follow the same steps, so let's go ahead and get started here. Now your steps are listed right here, and again, the very first thing you see is write the quadratic in standard form, and the only thing that changes here is that we need to take out a greatest common factor of a, b, and c if there is one first. Okay, if there isn't one, it doesn't matter, but if there is a greatest common factor of a, b, and c, we need to take that out before we factor. Then we're going to follow the steps to factoring, using the box method or the grouping method, whichever one you like. So we got a couple examples here. We should fly through these. Let's go ahead and get started. Okay, I got a few blanks set up for us to fill in here. On this one, we're going to use the box method for the first one here. And again, step 1 is to write in standard form equal to 0. Okay, so we're already set up in standard form. Then we want to look for a greatest common factor. Is there a greatest common factor of 2, 11, and 5? And there's nothing that goes into all three of those because 11 is prime, so I don't have to do anything different to start with. So over here I've got a spot to fill in what my b is. My b is 11. And I've got a spot to fill in a times c. Well, a times c, 2 times 5 is 10. And I'm going to write factors of a times c. Well, I know that I can do 1 times 10, or negative 1 times negative 10, or I can do 2 times 5, or negative 2 times negative 5 to get me a positive 10. Again, I want to pick the ones of those that are going to add up to b, add up to 11. In this case, it's 1 and 10. Alright, so now I'm going to take my first value. This time it's 2x squared. That goes in the box up here. And I can arrange 1x and 10x in whatever order I want. I just know it's positive 1x and positive 10x. And my last term is positive 5. Okay, well now I want to pull out my greatest common factors. So up here goes the greatest common factor of 2x squared and 10x. Well, now I've got a greatest common factor for the numbers, which is 2, and the greatest common factor of x squared and x is x. So 2x is the greatest common factor of these two things. Then up here goes the greatest common factor of these two. Okay, well the greatest common factor of 1x and 5 is just 1. I'm going to go ahead and throw a plus sign in there since it's positive 1. Okay, over here goes the greatest common factor of these two. Well, the greatest common factor of 2 and 1 is 1, and the greatest common factor of x squared and x is just x. And over here goes the greatest common factor of these two. The greatest common factor of 10x and 5 is 5. I'm going to put plus sign here because it's positive 5. Now I've got my two factors, 2x plus 1 and x plus 5. Again, I need to set both of those equal to 0. Okay, so I'm going to put 2x plus 1 equals 0 and x plus 5 equals 0. Well, to solve this one, I have to subtract 1 to start with. So I'm going to get 2x equals negative 1. And when I divide by 2, I get x equals negative 1/2. Okay, then over here, if I subtract 5 on each side, I get x equals negative 5. So my answers are x equals negative 5 and negative 1/2. Okay, so again, if I plugged those in, I should get the right answer. Okay, I should get it to equal out to 0 on those. Okay, so there's my solutions for that one using the factoring method. Let's go on to another example. Okay, this one we're going to use the grouping method on. So again, the very first thing we need to do is take this and set it equal, or set in standard form equal to 0. So I'm going to make it 12x squared plus negative 38x plus 30. Okay, well now I'll notice that my a, b, and c have greatest common factors. Okay, 2 goes into every one of those. So the very first thing I'm going to do is pull out 2. And then rewrite this. So 2 times 6x squared gives me 12x squared, plus 2 times negative 19x plus 2 times 15. Okay? Well, now I'm going to use this trinomial for my a, b, and c in my factoring. So we're going to go ahead and use, again, this trinomial for a, b, and c. So my a is 6, my b is negative 19, my c is 15. I'm not going to use these numbers since I pulled out a greatest common factor. Okay, well my b is negative 19. And my a times c, well, 6 times 15, that's 90. Now again, I want factors of a times c. They're going to add up to negative 19. Well, I know it's not going to be 1 in 90, so I'm going to go ahead and just start using common sense here. I know that negative 9 times 10, negative 9 times negative 10 will give me positive 90. And that's all I need because negative 9 and negative 10 add up to negative 19. Okay? So we're going to go ahead and use our grouping method here. And I'm going to go ahead and keep my 2 out front. My first term always stays in the grouping method. But now instead of negative 19x, I'm going to put negative 9x plus negative 10x. And I've got plus 15 on the end. Okay? Well, now I've got my 2 out front here, and then I'm going to group these two things right here. So I'm going to have times 6x squared plus negative 9x plus negative 10x plus 15. And now I'm going to go ahead and pull out the greatest common factor of 6x squared and negative 9x. So I got to remember I got this 2 out front. So this is 2 times greatest common factor of 6x squared and negative 9x. Well, the 6 is closest where I'm going to factor it out, so it's going to be a positive 3x. And 3x times 2x gives me 6x squared, plus 3x times negative 3 gives me negative 9x. Plus, now I've got negative 10x and positive 15. Well, I know the greatest common factor of 10 and 15 is 5. Since the negative is closer, I'm going to pull out negative 5. And negative 5 times negative 10x is positive 2x. Plus negative 5 times negative 3 is 15. Okay, and again, so what I should notice here is that my binomials in the parentheses are the same. That's good. So now I'm going to combine the stuff I've got here. So I've got 2 as one of my factors times, again, I'm going to combine the stuff outside to make a binomial. So that's 3x plus negative 5 times 2x plus negative 3. Okay? Now my job is to set each factor equal to 0. Okay? Well, here I don't just have 2 factors now, I have 3 factors because 2 is a factor. Okay, and I've got to keep that in mind because sometimes I might be able to factor out like 2x right away or something like that to start with. So I set each part I'm multiplying equal to 0. So I'm going to put 2 equals 0. I'm going to put 3x plus negative 5 equals 0. And 2x plus negative 3 equals 0. So again, notice I did not forget about my greatest common factor the entire way through this. Well, I know that 2 can never equal 0, so in this case, I don't have a solution to that one. So now I've got to solve these ones. Add 5. I get 3x equals 5, and then divide by 3. I'm going to get x equals 5/3, or 1 2/3. Then over here, we're going to add 3. I get 2x equals 3, and then divide by 2, and I get x equals 3/2, or 1 1/2. Okay, so my solution is x equals, again, we got no solution to this one, so I don't need to account for it. Okay, 1 1/2 and 1 2/3. And I could leave that as 3/2 and 5/3, but we'll write them like mixed numbers. Okay, so there's an example with factoring out a greatest common factor first. And now let's go on to one last example. Okay, and here we got a box method question. So we got 6x squared minus 2x minus 8. Now while I'm writing this in standard form here, I want to remind you that box and grouping are two different methods that you can use to factor these things. Okay, you can pick whichever one that you want to. Your book's not going to say use box method or use grouping method. These are just two different methods I've shown you. Okay, you use the one that you like the best. Okay, I personally like the box method better. So I like the way it gets everything organized, nice and neat. But again, it's up to you, your choice. We're just showing you how to use both. Alright, so again, now we got it written in standard form. We need to take into account, is there a greatest common factor of 6 and negative 2 and negative 8, which there is. Okay, and we're going to use the positive version of that factor because the leading coefficient is positive. Okay, so 2 is my greatest common factor of all those. And 2 times 3x squared plus 2 times negative 1x plus 2 times negative 4. Okay, so now again, this is the trinomial that I'm going to factor. So my b is negative 1. A times c, 3 times negative 4 is negative 12. And I want factors of negative 12 that are going to add up to negative 1. Well, I should be getting to the point now where I know my only possibilities are 3 times negative 4 and negative 3 times positive 4. Okay, and 3 plus negative 4 is going to give me negative 1. So this is the one I want to use. Now I'm going to throw this term in the top left-hand corner of the box. Oops, sorry. Let's try that again. 3x squared. Instead of negative 1x, I'm putting 3x plus negative 4x in either order. And then negative 4 goes on the end. Well, greatest common factor of 3x squared and negative 4x. The numbers don't have anything in common, so it's just going to be x. And the greatest common factor of 3x and negative 4, well, that's just 1. So we're going to go ahead and put a plus in between there since it's positive 1. Now the greatest common factor of 3x squared and 3x, well, the greatest common factor of 3 and 3 is 3. The greatest common factor of x squared and x is x. Then down here we've got the greatest common factor of negative 4x and negative 4. Well, that's just negative 4. So now I'm going to rewrite all the things I'm multiplying together, all my factors, not forgetting the 2 I had out in front. It's 2 times, we got an x plus 1 and a 3x minus 4, or 3x plus negative 4, either way. Those are all my factors. Okay, that would multiply out to equal what I originally started with. So now I need to go ahead and set each one equal to 0. Okay, so we're going to go ahead and make some space here. So we got 2 equals 0, x plus 1 equals 0, and 3x minus 4 equals 0. But we know that 2 never equals 0, so that's not true. Here we're going to get x equals negative 1. And on this one we're going to add 4. And then divide by 3. Get x equals 4/3, or 1 1/3. And now I've got no solution to this one, and then I'm going to arrange my solutions in order from least to greatest. So negative 1 comes first, and then 4/3 or 1 1/3, either way. And there's my solutions. Okay? So again, factoring. My favorite method for solving quadratics, because once you got the hang of it, it can go pretty nice and quickly. Okay, and there's a lot less squaring and things of that sort to do, where they're like in the quadratic formula. So, that is your lesson on factoring when the leading coefficient is something other than 1. Okay, so good luck on the homework.